Okay, let's try problem 5.39. Each of 100 identical blocks sitting on a frictionless surface is connected to the next block by a massless string. The first block is pulled with a force of 100 newtons. What is the tension in the string connecting block 100 to block 99? And what is the tension in the string connecting block 50 to block 51? Okay, so this is more of a conceptual problem than anything. So the first thing to realize is that let's pretend that all those separate blocks are actually just one solid mass, right? So we're pulling this with 100 newtons. And so the thing to realize is that each block in the system has to have the same acceleration or else they'll be bunching up and whatnot. And just from intuition, when you know when you drag a string connecting a bunch of things that they're all going to move with the same exact acceleration. So let's look at a more simple version of this problem. Let's just say we have 4 blocks. 1, 2, 3, 4. And let's say that these 4 blocks are being pulled by 4 newtons. So this is just a smaller version of the problem, just so we can gain some insight into this problem. So we know the tension in this part of the string is equal to the mass times the acceleration of the system, right? And so another thing that we also know is that the acceleration of this whole thing has to be the exact same. It has to be the exact same. So let's solve for the acceleration over here. So A is equal to F over m. So to accelerate these 4 blocks, we have to use 4 newtons. So the force to accelerate these 4 blocks for the total mass of the system is going to be 4 newtons over the total mass of the system. But now let's say we just want to know the tension in this part of the string between the last block and the next to last block. So this whole system, if we say that this system has a mass of m, right, the whole thing, all the blocks, all these are mass m, that means that each block has 1/4 of the mass of the entire system. And we know that the acceleration of the system has to be all the same. So we know that the acceleration of this last block has to be equal to, the tension in this last part of the string has to be equal to the force over 1/4 of the mass. Because that's all that this string is pulling, right? It's just pulling 1/4 of the mass. And so that means that this force has to be scaled by 1/4 as well to make sure that the acceleration stays the same. And so if we're pulling it with 1/4 for 4 newtons, that means that the tension in the string has to be 1 newton, right? Because 1/4 times 4 is just 1 newton. But now, so let's go back and think about 100 blocks. So for A, we want to know what the tension in the string is connecting block 100 to block 99. So instead of drawing out 100 blocks, I'm just going to scribble a bunch. And then we have block 99 connected to block 100. Now for this problem, we know that each block has to be 1/100th of the mass of the entire system, right? So this is 1 over 100 mass. So every block has to have 1 over 100 of the total mass of the system. But they all have the same exact acceleration like we did before. So we know that 1 over 100 times the mass of the mass. And that means that the force has to be scaled by 1 over 100 as well. And so the tension in the string must simply be 1 newton. Okay, now let's move on to B. What is the tension in the string connecting block 50 to block 51? Using the same kind of logic, I know that there's 49 blocks in front of block 50, and then block 51, and then a bunch more blocks over here. So the tension in this string's pulling 50 blocks. So that's half the weight of the entire system, right? If each block has 1/100th of the mass and you have 50 blocks, 50 over 100 is 1/2. So then we know that the acceleration has to be equal to something times the force over 1/2 times m. And we can see that we have to scale the force by half as well. So the tension in this string right here has to be 50 newtons, because 1/2 times the total force that's pulling the whole system. So 50 newtons is the tension. So 50 newtons is the tension in this string right here between block 50 and block 51. And that's problem 5.39.